Hello everyone, in this video we are going to talk about polynomials. In mathematics, expressions with one term are called monomials. Those with two terms, binomials, or more in general are called polynomials. Below are examples. Monomial, as we have said in the definition, is an expression with only one term. Example is 3x squared, 4xy, 2d, and lots more. Example of binomials are equations with two terms that are being connected together either by addition sign or subtraction sign. We have 2xy minus 3x, that's the binomial. X plus zy, that's another binomial. A squared plus b, that's another binomial. Here, our third example here is polynomial. Example of polynomials include binomial is actually a type of polynomial also. So an equation with two terms can also be referred to as polynomial. Either you call it binomial or you call it polynomial, is still the same thing you are talking about. So we have 2x squared plus y, that's the polynomial. X squared plus 3x raised to power 4 plus 6. Here we say that we have three terms here. That is a polynomial. Another one is 6x squared minus 2xy plus 3z plus 1, and lots more. So, polynomial with only one variable is called a polynomial in that variable. For example, 3x raised to power 4 plus 5x raised to power 2 plus 6x plus 3 is a polynomial in x. Why? Because the only variable in this polynomial is x. It is denoted by p of x. And our second example here is z raised to power 7 plus 3z raised to power 4 minus 2z raised to power 2 plus z. This is a polynomial in z and is denoted by p of z. So if you have a polynomial expression in one variable, then you call it a polynomial in that variable. The degree of any polynomial is the highest power of that polynomial. For example, in the above examples, the degree of 1 and 2 is 4 and 7 respectively, because the highest degree in example 1 is 4 and the highest degree in example 2 is 7. In polynomials, the powers can never be negative. That is, you can never have 3x raised to power minus 4. That is the power of your variable to be minus. That can never happen in polynomials. Each term has its own coefficient. For example, in 2 above, that is in the example 2 above, the coefficient of z raised to power 7, z raised to power 4, z raised to power 2, and z are 1, 3, minus 2, and 1 respectively. What we mean here is that the coefficient of z raised to power 7 is 1, coefficient of z raised to power 4 is 3, coefficient of z raised to power 2 is minus 2, coefficient of plus z is 1. Coefficient means a number before the variable. The constant term is the term that has no variable. For example, in minus 2x raised to power 3 plus 4x raised to power 2 minus 3x minus 7, the constant term here is minus 7 because it has no variable at all. Equations depend strongly on their variables. That is, the outcome of that equation depends strongly on the variable. For example, if p of y, that is polynomial in y, is equal to minus 4y raised to power 3 plus 3y raised to power 2 minus y plus 14, then our p of 1, that is, now we want, instead of inputting y here, now we want to, because we call this variable, it can take any value, we want to substitute 1 for the value of y in this equation. So we have p of 1 to be equal to minus 4 into bracket 1 raised to power 3. The reason why we are putting 1 raised to power 3 here is that anywhere you see y, you replace it with 1, because we are before it is polynomial in y, now it is polynomial in 1, that is p of 1. So anywhere you see y, you just replace it with 1. That's all you are going to do. So we have minus 4 into bracket 1 raised to power 3 plus 3 into bracket 1 raised to power 2 minus 1 plus 14, and that will give us 1 raised to power 3 is 1, so minus 4 times 1 is minus 4, plus 1 raised to power 2 is 1, 3 times 1 is plus 3, and minus 1 remain minus 1 plus 14, which is our constant term. So when we simplify it, we have 12 as our answer. We have 12 as our answer. Another example is p of minus 1, that is polynomial of minus 1. So instead of writing y here, anywhere you see y, what we are going to do is replace it with minus 1. So here is will give us minus 4 into bracket minus 1 cube plus 3 into bracket minus 1 square minus into bracket minus 1 plus 14. Please, we have to include the minus sign. You have to include the minus sign, and you have to introduce your brackets so that you won't make any mistake and you'll be able to expand your bracket correctly. So here minus 1 is still the same. Minus 1 raised to power 3 will give us minus 1. So we have minus 4 times minus 1 plus 3 times minus 1 raised to power 2 will give us 1, because minus 1 times minus 1 is 1. So we have 3 times 1 plus minus times minus will give us plus. That's why we have plus 1 here, plus 14, which is our constant term. So we have minus 4 times minus 1, that's 4. 3 times 1, that's 3, and 1 plus 4, that's 15. So we have 4 plus 3 plus 15, and that will give us 22. Look at the big difference. When we look for the p of 1, we get 12 as our answer, and when we look for p of minus 1, we get 22 as our answer. So when we say equations depend strongly on their variables, this is what we mean, that no matter what the variable is, will surely affect the equation. Now take this little test to test your understanding so far of what we have talked about. The first question says, give one example each of the following. Actually, have the questions like this. Just try and pause the video and give the answer to these questions. I believe you got all the questions right. So now let's go to addition and subtractions of polynomials. How do we add two polynomials and how do we subtract two or more polynomials? Addition and subtraction is done term-wise in polynomials. Below are examples of how it is done. Carry out the following operations. Number 1, add 2x raised to power 4 plus 3x raised to power 3 minus 2x plus 4 to 2x raised to power 5 minus x raised to power 3 plus 5x squared plus 1. Our second question says subtract 2x raised to power 4 plus 3x raised to power 3 minus 2x plus 4 from 2x raised to power 5 plus 3x raised to power 4 minus x raised to power 3 plus 5x raised to power 2 plus 4. Here is the solution. Now, in our 1, 2x raised to power 5, the one that has the highest power is x raised to power 5. So that's why we are writing it first. Just like when you want to add two numbers, that is 10 and 5. The first one you are going to write is 10 because it has tens and units in its place value. So the 5 can stand under 0, which is the unit. That's the same thing you want to do here. But what we mean by time wise is that the one that the powers of the variable will determine how you are going to add. For example, now look at these two polynomials in equation 1. One is 2x raised to power 5 minus x raised to power 3 plus 5x raised to power 2 plus 1. In this polynomial, there is no power of 4. That is, there is no x raised to power 4, and at the same time, there is no variable that has only one power, that is x. There is no variable in x there. And again, in our second equation, which is 2x raised to power 4 plus 3x raised to power 3 minus 2x plus 4, there is no equation there is no term in power of 5, and there is no term in power of 2. So that is why the space is being left, because there is nothing there. You are not going to add it to anything. So this is how the addition is done. The constant term will be added to the constant term, so that will give us 5. Here, the variable with power of 1 will be added to the variable with power of 1. Actually, up here there is nothing with power of 1, so we are just going to write down the variable with power of 1 back. Here we have 5s squared. There is no power of 2 in our second equation, so there is nothing to add this to. It's just like you are adding a number to 0. It will give you that number back. And here you have x minus x raised to power 3 plus 3x raised to power 3. Actually, they both have the same powers, which is x raised to power 3. So since they both have the same variable with the same power, what you are going to do is just add the coefficient, that is minus 1 plus 3. Minus 1 plus 3 will give us plus 2. So minus x cubed plus 3s cubed will also give us plus 2s cubed. Then we produce to the power of 4. There is nothing with the power of 4 up there in the first equation. So in the second equation, we have 2x raised to power 4. So it's just like you add 0 to a number. We are going to write that number back, and here we are going to write plus 2x raised to power 4 back, and the same situation happens to 2x raised to power 5. Here is the solution to the second question. Just like we have done in the first solution, here we are going to write them term wise also. The constant term under the constant term and the likes of the constant term under each other. So now 4 minus 4, which is the constant term, we have 0 because the operation here is minus. Here in the first equation there is no term in x, so it's still the same thing as writing 0x, but we did not write it there so as not to cause confusion. And in the equation below we have minus 2x. Just like if you want to subtract minus 5 from 0, that will give you 0 minus minus 5. So minus will multiply minus and you have plus. It will give you plus 5. That is the reason why we are having plus 2x here. It is 0 minus minus 2x. So the minus will cancel the minus and we have plus 2x. The term with s square, we have a term with s square in the first equation and no term with s square in the second equation. So plus 5s square minus 0 will still give us plus 5x square back. And in the term with s cube, that is the term with x raised to power 3, minus s cube minus plus 3s cube. Minus times plus will give us minus, so we have minus s cube minus 3s cube. Just add the coefficient, that is minus 1 minus 3, that will give us minus 4. So our answer here will be minus 4s raised to power 3, that's minus 4s cube. The next we go to term with power of 4, that is 3x raised to power 4 minus 2x raised to power 4. 3x raised to power 4, the coefficient there is 3, and 2x raised to power 4, the coefficient there is 2. 3 minus 2, that will give us 1, so we are left with x raised to power 4, plus there is no term with x raised to power 5 in the second equation, so it's just like subtracting nothing from 2x raised to power 5, which will give us back our 2x raised to power 5. I believe you understand this, so try to do the following exercise. I believe you are able to do all your previous exercise correctly. So let's look at how to multiply polynomials, that is multiplication of polynomials. Multiplication of polynomials follow the rule of expanding brackets, and since variables are included, the rules of indices are also obeyed. By now I believe that you have the knowledge of indices. Example: multiply 4x raised to power 3 plus 2x raised to power 2 plus 7x minus 3 by 5x raised to power 3 plus 2x minus 1. Here is the solution. Here, what we do here is taking each term of the first equation and multiplying it by the whole of the second equation, that is 4x raised to power 3 multiplied by the whole second equation, which is 5s cubed plus 2x minus 1. Then we take the second term in the first equation, which is plus 2x squared, and we still multiply it with the whole of the second equation, which is 5x cubed plus 2x minus 1 plus 7x. We take it, we multiply it with the whole equation, which is 5x cubed plus 2x minus 1 minus 3, that is our constant term. We also multiply it with the whole equation. So this will leave us with 4s raised to power 3 times 5x raised to power 3. This will give us 4 times 5 is 20, and according to indices, when the base are the same, we are going to add the power. 3 plus 3, that will give us 6. So we have 20x raised to power 6 plus 4x raised to power 3 times 2x. 4 times 2, that will give us 8. X raised to power 1 plus times x raised to power 3, that will give us x raised to power 4, because we are going to add their powers, which is 1 plus 3, which will give us 4. Now 4x raised to power 3 times minus 1, that will give us minus 4x raised to power 3. 2x squared multiplied by 5x raised to power 3, that's going to give us 10x raised to power 5. Of course, I've explained how we do multiplication of numbers, of terms with variables, and when you continue multiplying like that, you have the result you have on your screen. And so you collect the like terms and add the corresponding elements. The one that can be added together, you add them. The ones that can be subtracted together, you subtract them, so that you have your final answer. Here there is only one term with x raised to power 6, so you are not going to add anything to it or subtract anything to it. So you have 20x raised to power 6 plus, and again here you have only one term with x raised to power 5, so that will give us plus 10x raised to power 5. There is nothing to subtract from it, there is nothing to add to it. But when it comes to x raised to power 4, we have two terms with x raised to power 4, that is plus 8x raised to power 4 and plus 35x raised to power 4. So when we add 8 to 35, we have 43x raised to power 4 minus, we have three terms with x raised to power 3, that is minus 4x raised to power 3 plus 4x raised to power 3 and minus 15x raised to power 3. Minus 4x raised to power 3 plus 4x raised to power 3, that becomes 0. So we write minus 15x raised to power 3 plus, we have two terms with x raised to power 2. The first time is minus 2x squared and the second time is plus 14x squared. So when we take away 2 from 14, we have 12, and we have 12, we have 12x squared as our answer. Minus, here we have minus 7x plus 6x, that is the term with only 1, with the power of 1, that is 7x, minus 7x and plus 6x. They are only 2. So when you subtract minus 7x from plus 6x, you are going to have minus x, and the constant term here is only 1, which is 3. So that's why we have our constant term here to be plus 3. I didn't mean we have more than one constant term. Add everything together and the answer you have is what will be our constant term. I believe you understand how to multiply polynomials. So here is another example. X raised to power 3 plus 6x squared minus 3 by x minus 2. Just like we have done in the previous example, what we are going to do here is multiply each term. Just take any of the two equations. The most important thing for you to do is to make sure you multiply each term of the equation that you take by the whole of the other equation. So we have here, I took x minus 2 and I multiply x with the whole of s cubed plus 6s squared minus 3. What after x, what remain is minus 2. So we have minus 2 multiplied by the whole of the first equation again, and x multiplied by s cubed, that will give us x raised to power 4. X multiplied by 6s squared, that will give us plus 6s cubed. X multiplied by minus 3, that will give us minus 3x. Minus 2 multiplied by x raised to power 3, that will give us minus 2s raised to power 3. Minus 2 times plus 6s squared, that will give us minus 12s squared. Minus 2 times minus 3, that will give us plus 6. So just like we have been doing, collect the like terms and solve the equation out. Here there is only one time in the power of 4, so we write it down, x raised to power of 4 plus 6s cubed minus 2s cubed, that will give us plus 4s cubed. There is only one term with x raised to power 2, so we have minus 2s squared minus 3s, there is only one term with that too, plus 6, there is only one constant we have here. So here's our third question, that is into brackets 2x raised to power 3 plus x raised to power 2 minus 3, into brackets, close brackets, open bracket again, 7x minus 4, close bracket. What this bracket means is multiplication, that is, you should multiply both equations with each other. So this is the solution. Here I take 2x raised to power 3 plus x squared minus 3 as my equation. So what I'm going to do is multiply each term of that equation by the other equation. That is 2x raised to power 3 into brackets 7x minus 4 plus x raised to power 2 into brackets 7x minus 4. Minus 3 is our constant term, so we have minus 3 into brackets 7x minus 4. And 2x raised to power 3 times 7x, 2 times 7, that will be 14. X raised to power 3 times x, that will be 3 plus 1, and it will give us x raised to power 4. So we have 14x raised to power 4 minus 2x raised to power 3 times minus 4, that will give us minus 8x raised to power 3 plus x raised to power 2 times 7x, that will give us 7x raised to power 3 plus x squared times minus 4, that will give us minus 4s squared minus 3 times 7x, that will give us minus 21x minus 3 times minus 4, that will give us 12. And after adding and subtracting the like terms, after collecting the like terms, we have 14x raised to power 4, because x raised to power 4 is only 1 there, so you write it back, minus 8x raised to power 3 plus 7x raised to power 3 minus 8 plus 7, that will give us minus 1, so we have minus x raised to power 3. Here you don't need to write 1, since 1 is the coefficient. Any variable, we know that 1 is its coefficient when its coefficient is not written, so we don't need to put 1 there. Minus 4x raised to power 2 minus 21x plus 12, and that is the final answer. Thank you very much for watching. Subscribe, like, share. Subscription is absolutely free, so what are you waiting for? Just click the button.